motivated to make a positive impact in our respective fields.
May I kindly request your attention as we begin our gathering with a prayer song. Let us take a moment to reflect and connect with our inner selves. I invite Kaushika Rani and Kirtana from 2nd BSc Max for the prayer song.
परिपूर्णवाये प्रभो गणपते 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 साधुवनुकी तुझे पाड़ी आड़ी मुलन सन्निधि चरणडिंदोने साधुवनुकी तुझे पाड़ी आड़ी मुलन सन्निधि चरणडिंदोने शांत सिद्ध सौभाग्यमयावयं तन्मय सद्गुरु नीये तन्मय सद्गुरु नीये प्रभो गणपते परिपूर्ण वाळ्वरुळ्वाये प्रभो गणपते 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 गणपते.
Thank you for joining us in this soulful rendition. May the spirit of this prayer song resonate within us throughout our time together.
As the lamp is lit, let it symbolize the illumination of our minds, spreading of positivity, and the celebration of unity. I would like to invite the dignitaries to kindly come forward and do us the honor of lighting the lamp.
Thank you, dignitaries, for this auspicious act. May the light of this lamp inspire us all to strive for excellence and spread joy wherever we go.
Let us now proceed with the welcome note. I would like to welcome Dr. Uma N., Associate Professor and Head, PG and Research Department of Mathematics, to deliver the welcome address.
I request the Now I request the dignitaries to come to the dais.
Good morning to one and all present here. A warm welcome note to all of you. It's a great privilege for me to propose this vote of, to propose this welcome address today. Usually I used to give this vote of time. Every time I stand, very sorry. I would like to welcome all of you here. And then it's on behalf of Mathematics Department. Okay, it's a very privilege to have this one-day international conference on emerging trends in mathematics and statistics. On behalf of the department, all the members for the, I would like to welcome one and all for this one. And then we have our extreme thanks to our management for supporting this function to organize over there. So my first welcome note is to the resource persons of the day. First, I would like to welcome Dr. P. Geeta. Ma'am is the principal. Ma'am is the principal of KPR College of Arts, Science and Research, Coimbatore. I'm greatly blessed to have her with us today. And then I would like to welcome Dr. Rajashekharan Ramasamy sir. Sir is the Associate Professor and Head. Sir is heading the Department of Actuarial and Quantitative Studies. Sir is from Asia Pacific University, Malaysia. And then we are extremely happy to have both of them today, eminent persons here. Actually, any program what we start, the Maths department from earlier, whenever we start anything, ma'am is the first person I would always request her to come over this. I'm very happy to say to you all, we both of us, okay, we're friends, okay. We both did our UG and PG together. And then I'm very proud to say she's the principal of one institution. And then any program we are doing, I'm doing, so I will be asking her, please come. Okay, she immediately accepted. Heartfelt thanks to her. And then I will have her session today also. And then other person, Sir Rajashekharan sir. Sir has worked with us for the past 4 to 5 years. When I visited long back to APO, Malaysia, from that time onwards, 5 years, Sir has been associated with our institution. Sir is with us in our board of studies. He is our subject expert. So framing our syllabus curriculum and all, Sir is always guiding with us. Okay, so we always interacted through online, through mail only we have interacted. So this is the time Sir has came over here to grace us with us. So a very warm welcome address to Sir also. And then I would like to put my note to Vasant Kumar Borifay sir. The day one of my career in this circus, I'm traveling with Vasant Kumar Borifay sir and then with X. And then apart from that, from 2016 onwards, when we have grown into a separate department, now we are around 20 staffs here. So I would like to welcome each and every one of you for this program. And then another one, all HODs, different department HODs and the staffs for this noon. And especially my welcome note to all the students here, outsiders as well as the students from our college. A heartfelt welcome note to all. Have a good day. We'll have 2 sessions in the morning and afternoon we'll have the presentation. So my welcome note to each and every one of you.
I invite Mr. Vasant Kumar Boniface, Assistant Professor, PG and Research Department of Mathematics, to honor our Chief Guest, Dr. R. Rajsekharan. I invite Dr. Uma N. to honor our Chief Guest, Dr. P. Geeta.
I would like to welcome our chief guest for the session, Dr. P. Geeta. She is carrying more than 24 years of academic experience. She served as an associate professor and head of the Department of Mathematics at Banaryaman Institute of Technology, Satyamangalam, for more than 2 decades. She is associated with KPR institutions since the year 2020. Began as a professor and head Department of Mathematics, head first year program and head Science and Humanities at KPR Institute of Engineering and Technology, Coimbatore. With her great command, passion and dedication towards the work, she is inflated as principal, KPR College of Arts, Science and Research, Coimbatore. She is the gold medalist in Bachelor of Science in Mathematics. She received AICTE Leelavati Award 2021-2022 under the sub-theme Environmental Sanitation and Hygiene. Educational Icon Award as Best Mathematics Professor for the year 2021 and Distinguished Leader in the discipline of Science organized by the Center of Leadership Development in the year 2019. We are happy to have you among us, ma'am. Now I request the chief guest to address the gathering.
Thank you for your note. I am not that great, very simple and very humble. Oh, fine, sir. Very happy morning to everyone gathered over here. Esteemed guest professor from Malaysia, APU University, and my own friend Dr. Uma, and all the faculty members of Sri Ramakrishna College of Arts and Science, my student friends. So it gives me an immense pleasure to stand in before every one of you all, and I feel this college, it is my own college. So I don't feel that there is a difference between KPR College of Arts, Science and Research and Sri Ramakrishna College of Arts, Science and Research. So why? Because very frequently I am coming here at least once in a while, whenever they call me, like for whatever kind of a program they call me, I just come without saying no. So why? Because it is all because of the friendship we had. So why I am insisting that is that even when you go out of this institution, you should never stop your relationship. You should continue it forever. Whatever may the thing be, you will have to find time and you will have to share the knowledge. So why I have agreed here is that there are two kinds of things in my life. So I thought I also have a PPT, but I thought in a certain thing I should share whatever thing I have gained. So rather than having a PPT, whatever others say, if I make it a PPT, it will not be useful, it will be just like a theory class, that's it. So I thought I would share the knowledge, whatever thing I have gained. So one thing was gaining the knowledge, and the other thing is sharing the knowledge. So gaining and sharing are two important parts in our academics. So what we do is that the title today for international conference is Emerging Trends in Mathematics and Statistics, so which is an amazing topic. But people these days, you don't have a passion of entering into mathematics or statistics. Day by day it's getting reduced. Very pathetic situation, but one day or the other there will be a very huge demand for the mathematicians and the statisticians. At that time people will understand why they have missed out. See, this AI tools, whatever it may be, data science or machine learning or artificial intelligence or deep learning. So irrespective of any kind of an AI tool, without mathematics, you cannot do anything. So that is specifically if you are very good at probability, statistics and linear algebra, then getting into this AI tool like deep learning and data science, it will be very, very helpful. So why students lag in mathematics and science is that, and that too, after the COVID, many of the students hate mathematics. That too, +1 and +2. Why they hate is that because of integration and differentiation. So in those days when we studied, the teachers were telling us like what is the importance of differentiation and what is the importance of integration. So even if you enter into engineering or into any of the arts college, and if you want to do any of the streams like artificial intelligence or machine learning, artificial intelligence or data science, or computer science and business system, computer science with data analytics, or computer science plane and information, irrespective of any branch, you should have a basic and foundation of mathematics. Without mathematics, nothing cannot be done. See, if you just mug it up for the namesake, only at that point of time you will be able to recall it, and might be if your memory power is too good, you will be able to fetch good marks. But then as soon as the semester gets over, you will not be able to recall anything else. So my point is that whatever thing you learn it, try to find a real-time application. So real-time application is very, very, very essential. So what I am saying is that I told initially gaining the knowledge and sharing the knowledge. So gaining the knowledge in the sense, whatever your teacher says in the class, be attentive. That is the first point. So it is not simply being attentive to the class. Whatever the teacher says in the class, all the concepts, try to grab it. And the survey says that only 20 minutes you can be concentrating on one particular topic. Yes, of course, that is true. So that is why this OBE says that for every 20 minutes, you will have a gap of 5 minutes. What for that 5 minutes? So that 5 minutes, you can have any kind of an activity-based learning within the classroom. So 20 minutes, whatever the teacher says for one particular topic, you be very, very alert to it. Try to grab what has been taught by that teacher in that class. That is very, very important. So after that, you ask yourself, how I can apply this topic into my day-to-day life. So if you are answerable to that question, by the point whatever the teachers have been said to you, then you are really great. If not, you have got the electronic gadgets with you, so you can use it in a proper way. You can just Google it, and there are a lot of avenues and lot of platforms in this gadget. You can just find out what are all the real-time applications of the topic which has been built in the classroom. So those topics, you try to identify it and find the applications. After finding the applications, you will have to make a prototype. So making a prototype, it is not that very simple. So only after understanding the concept thoroughly, you will be able to make the prototype. So after making a prototype, then you can come out with a product. So once you are coming out of the product, you can go for patenting and then you can commercialize it. So what you are going to do, there are only 4 stages. So the first stage is that you will have to understand the basic concepts and the fundamentals of the emerging trends. Either it may be data science, or it may be any of the thing called machine learning and so on. So one simple question, what is the difference between this data science and machine learning? So if I ask you whether you will be able to give me a real time example. So I will also give you a hint. You might have watched Netflix, yes? Yes, you might have watched Netflix and then Facebook. So I just ask you where this data science is applied and where this machine learning is applied and why it's been applied. So you will have to ask the questions by yourself. See, in those days, we didn't learn any kind of an AI tools. Only after coming into this kind of an era, we are just finding out with gadgets and we are trying to find out where all these tools are being used. So in Netflix, data science has been involved. So why in Netflix data science and why in Facebook machine learning? So you will have to find out the difference. So the difference between these two is that data science, why it's being used in Netflix is that from that you collect data and then you do the analysis of the data. So after doing the analysis bit by bit, everything it will be combined together, pulled together and it will be made as one single frame and that is making use of data science. And why this Facebook is making use of machine learning? You will have to ask the questions again yourself. So machine learning, it is just a part of this data science. And I would also say that this machine learning, it is a subset of data science. You have a part and parcel of this data science as a machine learning, and here probability will play a major role. So here metamorphisms is done, but then it's not been done in Netflix. So that is why people make use of machine learning for Facebook. So for further references, you can just look into your mobile, you can just Google it, find out how it has been evolved. See, being a mathematician or being a statistician, it doesn't mean that you should not have an idea of all these things. So you have to take an updated version of everything what is happening in day-to-day life every day. So that is very, very important. After that, whatever knowledge you have gained with, try to share it with your peer mates. So once if you share your knowledge with your peer mates, you will not forget any of the topic, whatever thing you have learned in your life. So if you are not sharing it and if you just gain and if you keep it yourself, it will be within you only and it will not be multiplied. So if you want to help the society or if you want to help the students, share your knowledge. So when you share your knowledge, let it be a practical one, right? Not be a very old theory part, let it be an application part. So once if you are going for the application, then in the foreign countries what they do is that even in the 5th standard the students are asked to do the pattern. But we are only doing it when we come into post-graduation or undergrad. Why is there a lot of difference? See, what we people are doing is that if we are supposed to do or publish an article in a journal, we will just Google it, take out all the parent sources, then we find out the topics, then again we will Google it, from there we will be just taking it and making all sort of a morphing and we do it. That is how people are doing it. But in foreign countries, what they teach the students is that even they publish the articles in the journals, they are asked to do a pattern filing. So pattern filing, it is your own innovation. So innovative ideas, your creative ideas, it can be put and you can just give a small write-up. So article writing, it will be just a lengthy one and you will have to find out a solution for it, trial and error basis method. But whereas in patterning or filing a pattern, it is nothing else but whatever idea you get, even if it is a small idea, let it be. So you will have to write up like with 500 words and then you should have a design for it and after designing it, you will have to see to that whether it works and then you can file for it, you can publish and later on if it is good and if the examination is over, it will be granted. So after getting the grant for any kind of a pattern you do it, you try to commercialize it. Once if you do the commercialization, you will become an entrepreneur. See, it is not that all the students who are studying in the college they get the placement. No. So you all should be you all should not be a job seekers, you should be a job creators. That is very, very important. So it is not that always you should go on finding out a job whether which company will offer you or not. You try to provide job for the other students, for which patterning will also be helping for you. So why we ask you to do is that, so because whatever idea, very small idea, even if you get it, you try to give up a write-up of that, you try to make a prototype of that. After making a prototype, then they get to the product, then go for the commercialization. Once if you're going for the commercialization, definitely if you could just see a small amount which is coming into your hands with your own idea, then you will feel very happy at that moment. So that will be the kickstart for you, and once, so while if you get that to be done, next you will go with the extension of whatever idea you get it. So for which, if you are not having any kind of an idea, suppose in case if you want to go for pattern, is there any avenue for it? Yes, there are lots of institutes where they provide you the workspace. You can just go sit in the workspace. Even if you don't have any idea, you can just ask the mentor over there, and there are few mentors in the workspace 24/7 in few of the colleges. If you don't have any kind of an idea, you can ask them any idea if they have, and whether they could be able to help you out or support you out. Definitely people will tell you, and you can just get along with them, and they will be just giving you the outline of it, and you will have to make a meticulous plan of it, and you will have to get the prototypes. Stage by stage there are people who will be helping you out. So once it's been done, you can also become an entrepreneur. So these days it is not that, see, only the techie people will go on for seeking the jobs. But if you are the innovators or creators, you will be just creating a job for the others. So I wish for this generation to create the jobs and not for seeking the job. So hereafter we should all, like, however the students or the entrepreneurs in the foreign countries, they do it. So most probably they they stand on their own legs and they will be a startup. So startup will also fetch you a good idea. So once if you go into it, so when you go like either into a startup or into an entrepreneurship or your parents' business or any sort of a thing like this, apart from the placement, you should have a strong foundation and strong concepts of mathematics. That is very, very important. See, only the science background students can make things better rather than the engineering students that I have seen in my own time of experience. So what the engineering student does is that whatever technology they study, say for example drones, so they know like how to assemble the drone, how to make it fly, but they don't know what is the basic concept behind the drone and what are all the measurements, how the wing should be, like they don't know. Like they get the things ready-made, a tailor-made one, then they'll just join it, they'll boot it and they'll make the drone fly. That is what the people, they just apply the technology. But what the science student does is that they'll be very thorough with all the basic concepts, and you know what should be the foundation, what should be the thickness of the board, what should be the length of the any pipe or any wire which being connected in the board. Everything science people, like inch by inch, you will be studying in all the basic things, and that is why people say that the science students can do better than any of the engineering students. So why the scientists have been awarded? you just think, why are the scientists have been awarded? Because they have a very good basic fundamentals within. So once if you are done with the fundamentals, then anything if you achieve, anything if you think, you will be able to achieve it. So this is all from my own experience. I'm just sharing the knowledge with you. See, whatever thing I have gained it, I'm just sharing it. Whenever I get a platform like this, see that even though the topic was emerging trends in mathematics and statistics, and I also had made a PPT for about 15 slides. And while traveling, what I thought was that, what is the use of putting this PPT to all the students over here? Nothing doing. So somewhere I've taken it. I've just made the presentation. Definitely, I'll be just looking at the PPT and I'll be explaining. So that you can do it by yourself. Why should I stand over here? So when I stand over here, I should be able to share my own experience. So if the people are sharing their own experience, definitely that will be the boost for the audience. So at least out of this crowd, even if one student takes that point and if he or she is able to implement what you have gathered in this 1 hour or half an hour, that will make more sense. So I thought I should not go with the PPT, rather whatever thing I know, I can just share it with my own students. So that is why I didn't want to put it when Professor Uma asked me, like, do you have PPT? Yes, of course, I had a presentation, but I never wanted to do it, so I thought I can share my knowledge to you. So how I traveled into this? See, I did my UG with maths and physics double major. So when maths and physics goes together, we will be able to have a good foundation. Without mathematics, physics is nothing, and without physics, mathematics. So jointly it goes hands on hands. And next is MSc, I did mathematics and MPhil. PhD, when it comes, my specialization was fluid dynamics. So in fluid dynamics, I learned a lot. Like, it was not relevant to whatever thing I learned in topology or something else, but it was all of mathematics. Then computer science, I have to do the programming coding for the program to get run, and next is mechanical part was involved. So mechanical, computer and maths. It was wonder for me, but I strived for it, and I took a lot of pain for it. You will not believe me. Every day 4 o'clock I will just wake up. So when I registered for my PhD only in 2008. So my UG, PG, MPhil, it was completed from 91 to 97, and then I took up my profession as a teaching profession at Banari, and next is that only in 2008 I registered for my PhD. So even before I registered for my PhD, I thought, like, what should I do? So I learned so many things, but whether will I be able to apply it in my real time? Certain things I don't have an answer for it, but few things, yes. So I thought I can find out a suitable supervisor wherein he can teach me or he can guide me, where I can see the real-time application. So he told me, like, you can do it in fluid dynamics. I said yes. So fluid dynamics, then I took a few months to learn what is all about it. Then he gave me a broad line. So you will have to come out with a program like how to convert an ordinary differential equation, a partial differential equation into an ordinary differential equation, for which I will have to make a code. So coding, I don't know anything. Right? So then I sat and studied my C and C++ for about 6 months. Right? So it is all self-study, and in my college I had my own colleagues, computer science department. They helped me out, and whenever I had a doubt, I'll approach to them and they'll be just helping out me. So everything it all went, and I stood with C and C++. After that, I again approached my guide, and he said, okay, fine, you can go now. So we just took the mechanical field part, that is the plate. So once if a plate is taken, how we cut it and how we will be able to make a product, that was very, very important. So transformation has to happen there. So the transformation is nothing else but the coding part. So coding, so however, I had a background of mathematics, but computer had played a major role there. So the transformation was from mathematics to mechanical to via computer. So this was my small prototype I thought, and this is how I got knowledge into it. And after fetching that knowledge, so how to transfer? So transformation was by Navier-Stokes equation. So that Navier-Stokes equation, I didn't know what was all about that. Again I studied. So it is all still self-study. Once if you sit and study for like hours together, you will be able to understand at least certain things, and then again and again, if you are not able to understand, you can just Google it and you can find it out. So that is how the transformation had brought in me from mathematics, then computer, then finally I landed up with the result of my PhD. So after that, I didn't stop with that. Still now I am doing the PDF. So again, I'm just extending my field. So till today, I keep studying. See, it is not that always known is only a drop, unknown is an ocean. So we have to study, we have to update our knowledge. That is very, very important. So my kind advice at this juncture is that all the students, whenever you are having a free time, leisure time, go to the library. So you can ask yourself, how many hours of time I am spending in the library? No, all of you will have to believe and you will have to agree, not even half an hour you will spend in the library. But in those days, we were used to go to the library and we will search for the things, whatever thing we needed. But you people, now you have got electronic gadgets. Yes, of course, that is also good. But the thing is that taking a hard copy and reading it and seeing a soft copy in your mobile and reading it, there is a lot much of a difference. So we had a kind of a thing, a hard copy and looking into all the materials and then we got it. But you people just make use of all the AI tools. See, AI tools to certain extent they help us. But the thing is that if you don't understand the concept, that is mere of waste. So even if you want to do something else, or if you want to give any kind of a talk in ChatGPT, now everybody has got, and you would have installed in your mobile. So if you just give the title of the topic, whatever thing you want to deliberate in the meeting hall, you can just give the title of the topic over there, and it will give you like what you are supposed to talk. So it is tuning you. You are not tuning yourself. The gadget is tuning you. So you should not be like that. So whatever you wanted to do it, you will have to put your heart and soul, and then you should have a passion for it. So once if you have a passion for it and if you have a fire for it, then definitely whatever thing you think you will be able to achieve it, and one way or the other you will be standing at the topmost position, and you will be a unique person who will be able to differentiate between the rest of all the others. So that is how we people were like that. So like in those days, whatever thing we gained it from our teachers, we were having a group discussion also. Whenever we find time, we will sit in a group and we will also share the knowledge, whatever thing we have gained it. But we don't look these days. See, whenever you people are in a crowd, what we talk about is that what movie you have to go for and where you will have to go, and today evening which restaurant we can all meet there, and how happily we can enjoy your life. Yes, of course, that should also be there. But the thing is that you should also have this kind of a nature. Sharing the knowledge is very, very important. So once if you have that kind of a thing, definitely you can be a best person in your life. And you will be the role model in your family. For your younger sister or younger brother, whomsoever it may be in your family, they will look at you, they will salute at you. But everything if you're depending on somebody else, and on one fine day you will not have anything in your life. So now it is right time, and I request each and every one of you, at least from today onwards, whatever emerging techniques you study it, at least have some deep knowledge about whatever thing you have studied. So once if you are having that kind of a nature, automatically For each and everything, if you are going to find, coming across any new terminology, you will just look into its vocabulary, or you will just Google out, find what is its importance and what significant role that particular technique has, and then how it can be applied in your day-to-day life. So all these things you will be able to find it. So at least from today onwards, I will request everyone, like at least one small topic, whatever thing it's been taught to you, one particular word, you just take it and you find out what is its real-time example, implement in your life, implement it in your life. That is very, very important. So once if you are implementing it in your life, never and ever you will forget the concept. And even years ago, if it is going on, and one fine day, if somebody is asking you what is all about that, you will be able to give a very good live example, even more whatever thing you have learned. So it is all by means of experiential learning. So experiential learning is very, very important. So in this forum, I could say that even though you are from mathematics background or from statistics background, you don't stop with that. You go into the techies of this kind of a era. So now booming thing is artificial intelligence and data science, artificial intelligence and machine learning. And of course, you also have topological data analysis. What is all about this topological data analysis? Anybody, any idea? So this topological data analysis, what it says is that if any shape is given to you, right, if any shape is given to you, you will be able to grab the data from that topological data analysis. See, always once if a data is given, you will be able to make an analysis of whatever thing you need, and finally you will be able to summarize it with the result. But this topological data analysis, what it says is that any shape or any figure it's been given to you, you can derive a data out of this topological data analysis. Using it, you can arrive at data, and from that, whatever thing you want to do with, you can take a bit by bit, and then you can pull whatever result you need, or whatever concept you are going to apply it, you can apply it for the data, whatever it's being used through topological data analysis. So there are so many number of tools like this, only thing is that we are not aware of it. So at least try to have a knowledge of what's being done. Next is deep learning. What is the difference between data science, machine learning, deep learning? So whenever you study each and every terminology, you should be able to differentiate between at least any two or any three. See, when you are buying a product on an Amazon, how you do it? Is anybody teaching you? No, it is all out of your own passion. You are making an analysis of yourself, and you are also finding out the rating of that particular product, and then you are ordering for it. Likewise, whenever you are studying also, you will have to make an analysis by yourself, and you will also have to rate which technology is more apt for my own application, and then you will have to come to a conclusion. That is very, very important. But we don't concentrate on this kind of a thing. We concentrate, like, if anybody asks whether you have seen this movie or this movie has been released, are you going to? So even before you go for the theater, you just book, even before booking the ticket, what you do is that you just find what's being done. So who is the director, who is the hero, who is the heroine, and let's see who is the singer, who is the producer, and you find out the rating. So you have much of a passion to do all such kind of a thing. Why don't you find little time to find the analysis of the topic which has been dealt in the class? That is what is essential in day-to-day life. So all these things, whatever you do, like for buying a product on Amazon, or going for a paper, or going for a restaurant, it will not support for your long run. So if it has to support for your long run, it is all the terminologies, technologies, and implementation part of any kind of an application into a day-to-day life, which is very, very essential. So my humble request to everyone is that whatever thing you study, this today's topic, it is a very good topic. So emerging trends in mathematics and statistics, we don't find people in mathematics and statistics these days. Strength it's been decreasing day on day, but one day they come, and in that day it will be most wanted for mathematicians and statisticians. So without stopping with this maths and statistics, you should also focus on to the advanced technologies like data science or artificial intelligence or machine learning, irrespective of any kind of a terminology. So after integrating all these tools into your mathematics, then you will be one day a different person in your society or in your family, and everybody will salute for it, and we hope one day it will happen for you, and you will also think one day, like I've been in this conference which has been organized in Sri Ramakrishna College of Arts, Science and Research, and that day one professor, she came and she told me, like, what should happen in your life? That is how we have to carry on forward, like what's been previously built in our sessions. So I hope everything, whatever thing I just shared, my little experience, you can take it a little bit forward, and you can do the analysis of yourself, and you can make your future a brighter one. My good luck to everyone. Thank you here.
Thank you for enlightening us with your insights, ma'am. Now it's time to release the book of abstracts. I request the dignitaries to come to the dais. Thank you, dignitaries.
In this note, I would like to address you all. See, we thought of having, I would like to introduce the writing habit for our students actually. So we started this, for our third UG and first PG students. We thought of them to have exposure, what is the article, how to write the article. In that part, only the journey starts, and that it ends with that international conference actually. We want to expose you to this, how to write one article. So that's where it started. Now we have around 140 articles today. In the beginning I started with, I actually emphasized and made it compulsory to write it there. But see, today we have around 140 abstracts here. Only the abstract is this much. The proceeding will be releasing on the 29th. So this is our journey of the book. And we are very happy, the department members, each and every member, they have spent so much of time there. All the staff, they've guided you how to write an article.
each one of them, okay, they've guided 2 members like that. And then now I think you all people know what is the article, and at least to start with the article, how to write. Am I right? And then we are very happy today to introduce it before us with 2 eminent persons, Dr. Geeta ma'am and Rajashekharan sir. Thank you.
Now it's time for a well-deserved break. We invite you to indulge in some refreshment and mingle with your fellow participants during a tea break. Before we adjourn for the break, a gentle reminder to please return to the conference hall by 11:25 as we have an exciting session lined up.
Actuarial and Quantitative Studies, Head, Accounting and Finance at Asia Pacific University, Malaysia. Apart from academic, he has had successfully implement various strategic optimization and turnaround projects. He was one of the members in the strategic team in restructuring and optimizing trade winds plantation. He was involved in the planning and implementing project under Polyamp AB, Sweden in Royal Malaysian Navy LCS project. He was one of the member of the restructuring committee, Albuquerque International University. He has 24 years of experience in teaching and managing at public and international private universities. On the teaching aspects, he has taught various levels and awarded twice for excellent teaching by Ministry of Education, Malaysia. He has obtained his PhD, MSc, BSc Honours in Mathematics and Diploma in Teaching Mathematics. He has presented in various platforms such as Tokyo, Tehran, Hanoi, Stockholm and published several papers in international publication and had written several mathematics and statistics modules. He is well versed with the wide-ranging academic department with international population of instructor and students. He has the experience to strategically transform his unit into excellence to achieve greater results. His areas of research are number theory and mathematics education. He has published around 14 papers in various journals. We are happy to have you among us, sir. Now I request the chief guest to address the gathering.
Good morning, everyone. Nice to meet you. Okay. It's not first time to India. I've been to India many times, because my great grandfather is from India. Okay, so I'm Indian as well as you. Okay. Before that, Dr. Uma is not here. I'd like to thank Dr. Uma because inviting me. And actually, I've been with the college since 2019. I'm one of your board of studies where we review your syllabus, everything. And I'd like to thank Mr. Vivek and Mr. Infan is not here. Mr. Vasanta. Yeah. They give me a good hospitality. They give me a good lunch yesterday. Thank you very much. Okay. All right. Now, like what Dr. Gita mentioned, that people have less interest in mathematics, right? Okay. Why you choose mathematics? I don't know. How many of you are enrolled in this course because you love mathematics? Please raise your hand. No one loves mathematics. It was quite sad to see. You don't. Why are you in this course? Because your parents forced you to come in? No, because you love maths? How many of you, yes, you love maths? Okay, thank you. How many of you are here because your father say you better go, you better take maths? Yes, you are there. Because your parents forced you to take maths. You wish to take maths, that's good. Okay, alright. Same thing, when I want to take maths, my father says no. I will say don't take maths, what are you going to do? But I love maths. I love maths from when I say 6 years old. 6 years old, when we go in the car, what I'll do is, you see the car in Malaysia, the car got 4 digits, right? So what I do when we go in the car, I always say, of course I talk in Tamil, see the number there, so I'll calculate, oh, this is 34, that is 46, this is 47. I used to do that. I think my father will say, shut up. Okay, because I keep on talking. So my maths is love so much. Okay, and I amazed with maths, especially the Indian maths. Of course, before everyone know what you all people should know Ramanujam, right? Right? Ramanujam is fantastic guy in number theory. Because my specialty is number theory. But I learned history in maths before Ramanujam. We talk about Aryabhata, the case. So fantastic. The mathematics in Indian, that Indian invented and start up. Even Pythagoras theorem was existed before the farmers in the river Nile started. Right? In India, we started the Pythagoras in constructing altar. I think I shouldn't go into that. But okay, thanks. Okay, but I look into the title of this conference, Emerging Friends in Mathematics and Statistics. And I have a chat with Dr. Uma and Mr. Vasan today. They say the number of people in mathematics are getting smaller. So what we need to make is to make relevant mathematics to be relevant with the today's technology or today's application. What do you mean with today's technology or application? Okay, when we talk about the world scenario, the economic scenario, first we're talking, okay, Dr. Uma is here. Okay, right. We talk about what changed the world scenario is the revolution. You know what's revolution? You heard about revolution? How many of you heard about revolution? Industrial revolution. You heard about revolution, right? Because today everyone is talking IR 4.0. You heard IR 4.0? Yes or no? You're university students, you're college students, you should know what's IR 4.0. Industry Revolution 4.0. Okay, let me tell you a story. Because these will change the world, the paradigm shift. We move something, a quantum thing in everything what we do. Those days, when humankind found steam power, you know steam power? Steam engine power? You know what steam? You boil the water, the power, steam engine. Okay, that is the first industrial revolution. So everyone dropped everything, everyone moved to the steam engine power. Manufacturing, car, transport, vehicles, everything going for steam engine. So then everyone was thinking how to utilize steam engine. So where mathematicians and statisticians come into the picture. We model the turbines. How many rotations of turbines? What's the power of the steam to move the turbine? How big should be the turbine? How light should be the material? These are mathematician role. Then come a different era where we found electricity. There's another industrial revolution. People drop the steam, they move to electricity. Then how to utilize electricity? The electromagnetic power. So we move. I saw one of your paper talking about electromagnetic field, which is good. I'll tell a story later bit about electromagnetic later. So people move everything. So move to electricity. Then come in 1950s, people drop electricity. Come a new revolution, which is computer. In 1950, computers were invented. Everyone start using computer. Then our role, mathematician, why do you use this computer? So we need to do some modeling, everything by using computer. And today, we're talking about 3 or 4 years back, IR 4.0. IR 1.0 is steam engine, 2.0 is, what guys? 1.0 is steam engine, 2.0 electricity, 3.0 computer, 4.0 AI, artificial intelligence. So we, as mathematician or statistician, have to make use, to make an impact, to be significant, to be relevant. So we won't, that means people appreciate the contribution. If you look, the application of it, very thorough application. If you eat potato chips, if you eat potato chips, yes or no? Yes. How the shape of potato chips? How the shape of potato chips? Oval. Mathematical terms. Anyone can give me mathematical terms? Potato chips, mathematical terms. If you eat Pringles, red Pringles, yes, Pringles in a canister, how the shapes look like? Mathematical terms, any one of you? You're mathematics students, eh? Hyperbolic, paraboloid. The name of the term is hyperbolic, paraboloid. Why hyperbolic? Because of the curve. Why we call paraboloid? Because you do cross section of the potato chips, it's a parabola. Doesn't matter which angle you cut. It's a you know it's parabolic, right? Okay, so that's why it's hyperbolic parabola. And that shape was modeled in 1956 by a guy known Frederick Bau. He's a mathematician. Why? Because he need to solve a problem. That's why you're supposed to be. You're a mathematician, solve a problem that relevant to people, to industry. A simple problem. You know what's the problem that time? Potato chips, when I buy, always crumble. Now you buy, still crumble? Less. Because the shape was designed to make sure the potato chips don't crumble. So you see Pringles, you buy Pringles in a canister, you see they have to stack one after another. Alright? And if you found most of the time, it's nicely in the shape. It won't break, it won't crumble. Why? Because of the shape designed to reach the stand. Because you stack one after another. So that need mathematical modeling. So what kind of shape when you put on top, potato chips are very fragile. When you put on top, it won't crumble. So mathematics, Frederick Bauer developed that model. That's the application of mathematics. Until today, there are no better potato chip shapes that better than Frederick Bauer's model. Okay, so how much mathematics? So this is relevant. So how much, now your challenge is to make sure you are relevant to the society, relevant to the community. That is emerging trend in mathematics and application is not stick at what you do in mathematical level. See what is the application in real world. For that sake, in my school, in APU, the School of Mathematics, Actuarial and Quantitative Studies, we have a research cluster, a research team. We name it a mathematical modeling and statistic application in community well-being. When we talk about community well-being, why is community well-being? Have you heard about UNESCO SDG? How many of you have heard about UNESCO SDG? Okay, like what Dr. Gita mentioned earlier, you should be aware of what's happening outside of the world, not outside of the campus, outside world, in the world. You need to be relevant. Okay, SDG, UNESCO SDG is to make a world a better place. We talk of better community, healthier community, healthier environment, and this is where mathematician can play a role. Like what we do in APU, we have few people working in few projects. One of the project we're talking about road safety, because we found the problem in Malaysia, a lot of accident contribute to fatal injuries. You know what's fatal, right? Death. So this is one of the concern of the UNESCO. Because of the road accident, the country lost 40 billion per year in terms of productivity. So there's a big problem need to be solved. So who to solve that? Authority, right? The government will solve that. But how the government will do? They need to design roads. They need to design proper marking on the line. So who will do that? So mathematician, we do a modeling, we do a prediction modeling, we do a derivative, we use the rate of the accident based on the lighting of the street, the markers, how clear the markers on the street, how big is the shoulder, road shoulder. We do a modeling of that. So presented to the relevant authorities. So to reduce the number of accidents. So we are impactful. The mathematicians are impactful. So we can make the government change the policy. Not the government, the authority, to make the world a better place that will align with the UNESCO or United Nations SDG, bringing a better, healthy city. That's one example. Another example, we look at health. In Malaysia, one of the biggest killer, not in Malaysia, in the world, biggest killer of health, the silent killer is cardiovascular disease, CVD. Alright? You know, I think in India, the same thing. Because in India and in Malaysian Indian, it's a bit obvious because of genetic. Our genetic, our vessel size, everything will create that. And currently, and the lack of physical activities, and with you people now, a lot of screen time. How many hours you in the screen? Watching Instagram, TikTok, kind of thing, right? I don't say it's good, it's bad, okay? But we want to see how much that hours link to the risk factor. So the project that we do is, we predict modifiable risk factor. There's two risk factor, modifiable and non-modifiable. Non-modifiable is your genetic, your heritage, your age. Modifiable is your activity, physical activity, screen time, the type of food you eat. So we do a prediction. We do a rate of how much blood flows. The rate of blood flow, blood pressure can give a good blood flow. You learn derivative, you learn integration, that's where you apply it. And you develop a model. Together with the statistician, we develop a regression model. So in mathematics, two, mathematical modeling and regression statistics, you can develop a regression model. And we use that to predict. So we're going to plan to develop an app. By using an app, you put your screen time, everything, we give you, at the age of certain level, you have the risk factor. So these are things that you make relevant. These are emerging trend of mathematics. To be relevant to the society, you have to make impact. You see, when people love mathematics, if you look now as what Dr. Gita says and talk to Dr. Vasanta just now, they say, people have no interest in mathematics. Why? Because people don't see the impact. Actually, mathematics is the backbone. You heard about blockchain? Anyone heard about blockchain? Fintech? Financial technology? Okay, maybe I'll talk a bit alien language here. Because fintech, blockchain, to develop blockchain is something great in financial world now. Okay, but to develop blockchain, we need to come from a mathematical model we call hash blocks. Hash blocks come from linear algebra. You learn linear algebra in classes? So what do you do with linear algebra? You calculate the eigenvalue, blah, 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 right? But you need to see how it applies. That is your challenge. See how it applies. Next time, if I like to see another conference when Dr. Uma organize, if possible, maybe I'd love to take few of them under my care. Some of you, you can work on some projects relevant to the application of mathematics. Okay, there are a lot of data outside there. And, okay, I give you one simple example. This one I have a chat recently. How much you believe in the birth chart? You know the birth chart? We call Panjangam. Panjangam is one. Panjangam, Panjangam, okay. Okay. When you born, your parents look Panjangam, right? The date you born, the time you born, correct? Correct? And they determine, they write a book, almanac, okay, you will be a good, you can be a doctor, you have this kind of thing, right? Okay. But what we did in Indian tradition, we just stop at that. And it's become part of our culture, just like that. Okay? Not to compare, but you look in Malaysia, the Chinese have a similar Panjangam. Alright? But they now develop an app. Example, if you go to interview, you have one your academic, whatever credential you have. Another one you will sit for aptitude tests to see where's your liking. Another one is your birth chart. The data is outside there. So what they did is they pick up the few successful businessmen, successful engineers, successful doctors, and they're compared to their birth chart. Because when in machine learning, if you go in machine learning, we have testing and we have experimental data. You have 100 data, 70% you do to develop a model, another 30% to test. So they take this data and develop a model, a prediction model, and test it whether this Panjangam true or not. And it's proven. And now some of the companies to groom potential leaders to take over the company, they're looking at that. So what we are doing it, we have plenty of data, but we stop at, sadly, we stop at what? We look how to overcome the problem. How to overcome the problem, then the priest say you must do 10 times and 20 times whatever ritual you need to do. But we don't use it for scientific reason. Do that as prediction. That's a fantastic data we have. So what I'm saying that here, when you doing a project, Emerging Trends, I went through few of the models, just scrapped through. She gave me 5 minutes only to look at the big book, right? So one of the like electromagnetic, how much it influence? There's a big data there, okay? One of the project I saw, thanks to the lecturers who designed this, it's quite interesting. It catch my eyes because part of my project previously industry. Give me 1 minute, eh? Okay, better. Okay, what I saw this by K.P. Vilasini. And who is that? K.P. Vilasini. Not yet. You did a good project, models of perishable product incorporating supply chain management system. Who's that? KP Vilasini is not there. Okay, that's good. No, that's okay. That's good because that is a very good project. This is relevant to supply chain management. This is relevant to economy. Okay, look at economy. This is what people want. Because in supply chain management, what's the issue? This is able to solve. Because supply chain management, you're talking about warehousing. Sir must know, operation research. We do operation research when we do a neural network. How much things to move fast from one point to another point. Because that's the problem. What lies into that is perishable product. So perishable product have to go from the place that we generated or we produced to the user at the shortest period. And one of the classical example is salesman problem. Yes? Travel salesman problem is a classical example of neural network. So this is very good model that I've seen. We need this kind of project to show how significant are mathematicians to the world. Okay, so we look project, another one is electromagnetic, I saw. I can't get it, maybe just now I saw very fast. Okay, it's okay. Okay, this one by Jay Shankar. Stochastic modeling. Forecasting of food grain production. Jay Shankar is here? Not. Okay, awesome. Then a fantastic modeling. Forecasting food chain. Because these are issues that we need to food grain productivity. And in Malaysia, we have problem. Because India stopped exporting their rice. So when India stopped exporting their rice, Malaysia was short of rice. This happened last November. So Malaysia rice price double ups. Okay? Because no one did the forecasting model or the productivity. So this is kind of model that relevant to the economy. Okay? Maybe you think what you study differential equation. Like sir, actually you study ODE, differential equation, and ask whether you do numerical method or that. Yes, you say yes, numerical method, but it's a different course by itself. But you study differential equation, partial differential, you talk about heat equation and kind of thing. But where do you apply the differential equation? Where you really apply the differential equation? So I was academic, I started as academic, then I quit academic, I joined industry. I joined two industry, one on the plantation, another one on defense industry. Defense industry, in a war vessel, we developed a model of electromagnetic. So here I personally use differential equation. For warship, see what mathematician have to do with a warship? So we develop a weapon, a system to make a ship undetectable by sea mine. You see, a ship, when it moves, what he gain? Electromagnetic. You learn physics a bit, right? When a ship moves through the sea water, he develop electromagnetic. So, how, if see the enemy, they can see the ship, they put a bomb. But normally they don't do that. They plant bomb in the seabed. Landmine is called sea mine. So this sea mine will activate when the ship goes up with a higher electromagnetic. So the ship goes, higher electromagnetic, it detect, boom. So what we did, a mathematician, so I was part of the team, we worked with some Swedish researcher, we developed a model to neutralize the electromagnetic as it goes. Mathematic modeling, and the way the backbone is a derivative, ODE, differential equation. But we did numerical method because we go part by part, every inches of the stick body. So this is application. So I want you all to think, when you take MSc or BSc in mathematics, you study all the basic, and I talked to Vivek, talk about real analysis. So everything, the boundary point, everything are important. So when we talk about, you need to think what kind of problem in the real world can be solved by this fundamental, your linear algebra, your calculus, multivariable, integral, what can be developed. Okay, this is something, put in your mind. When Dr. Uma or your lecturer asks you to come up with a project, think of something. Data is outside there, underutilized. Okay, nowadays people are talking about machine learning. Everyone talking about machine learning. It's AI, right? So machine learning, you have two machine learning, right? Talking about supervised and unsupervised. Okay? This supervised machine learning, the backbone is regression analysis. The backbone. But it's not normal conventional regression. It may be multinomial. We're talking about nominal data kind of thing. So that's we create the supervised machine learning. Okay? Then the machine also will learn by its own, by unsupervised. So the backbone are the mathematics modeling. Artificial intelligence is still artificial. The backbone to generate the artificial is mathematics. Right? Like what happens to your plagiarism. You do some plagiarism. What software you use to detect plagiarism? Yeah. What called? Urkun. Okay, how Urkun? I don't know how Urkun works, but in Malaysia we just turn it in. Okay, how turn it in work is mathematics. You just make sure very simple mechanism using text sentiment analysis. Make sure they know exact 6 words in a row, then it is captured as plagiarism. Simple mathematical model using text sentimental analysis. Very straightforward. So this is the point, the things that apply in real world. So the backbone is always mathematics. Always mathematics. That's why you learn, if you talk about, you learn by historical, in those in Greek civilization, the mathematician known as the priest, because they the one who connect the metaphysics between the physical world and the virtual world. Because they can develop the relation. This is what you're supposed to do. Okay, so think wise what you can help to make the community a better community, a country a better country. By not need to think big, you don't need to be a politician, but think how you can make it big by looking at small things. Example, the potato chips. So make an impact. So next time when you do a project, think how much you're going to impact to the society. And that can maybe develop you, like Dr. Gita said, an entrepreneur. Or someone hold the patent. You can be someone bigger. Okay? Do not stop. Do not stop. We lose so many, in India we have developed, we invent a lot of things. We invent zero. We invent infinity. But where we are now? How much been applied? We are proud of history, but it's not enough. We need to show we are relevant to the current. That's why we are relevant to IR 4.0. Artificial intelligence, lot of use mathematics. Machine learning, lot of mathematics. Then where we are, look into that. So when you talk about emerging trend, look into that. Okay? Of course, a lot of things have been done in pure mathematics. I'm a pure mathematician myself. But I need to, not to change, but to find where I can find loopholes, where I can problems to use my fundamental knowledge to apply. So to make you relevant. Because in today's world, even in business world, in economy world, is always data-driven decision making. The keyword is data-driven decision making. So this data is there. How to make it decision making is a mathematical modeling or statistical application. So you need to be part of that. If you can be part of that, you are successful. Every industry needs you. Because I am developing actuarial students. Actuarial students traditionally are insurance and wealth management people, risk management people. But in today's world, they are work in petroleum. They look at fluid mechanics. They talk about the velocity of the petrol. The velocity of the petrol, how much velocity, how the pipeline should be, how thick the pipeline should be, how the gradient of the pipeline should be to optimize the petroleum production, in manufacturing as well. How much is a line to be optimized? The operation research took a lot of things on that production line to optimize the resources. This is something, look, you go to any single factory because Mr. Vasan say you're popular for textiles. If you manage to go to any textile, see how the production lines do, how to optimize it, right? How much raw material? You learn linear programming, basic optimization, yes or no? Yes, how you develop. Do not just confine yourself to just to draw some graph, find a region, this is spot. That is simulated problem. Go and find actual problem, part of your project. Apply that, solve it, and the industry will reward you nicely. I'm in industry, I was in industry, I was in plantation. We managed to turn around a 10 largest plantation company to profitable. How to look into this? My model very simple. We look at the plantation, palm oil. Maybe I don't know whether you've seen palm oil before. Palm oil, how much fertilizer you to put to see after 3 years what are the fruit, type of fruit, quality of fruits. And to see the company to gain. Normal fruits can go for 12 tons. We managed to bring it to 40 tons. Through mathematical modeling. So that's been rewarded, and I was rewarded nicely. Okay, so this is where your challenge. So mathematics is very, very niche and very impactful if you tap it rightly. The important thing, open your eyes, any single problem, small problem, you can be a millionaire. Okay? All right, I think that's it. Thank you very much.
We will cherish your words of wisdom and look forward to applying them in our personal and professional lives. Thank you, sir, for adding immense value to our gathering today.
Ladies and gentlemen, Ladies and gentlemen, distinguished guests and esteemed speakers, as we draw near to the conclusion of this enlightened conference, it is my honor to extend our heartfelt gratitude to all who have contributed to its success. I would like to invite Mr. Vasant Kumar Boniface, Assistant Professor, PG and Research Department of Mathematics, to deliver the vote of thanks.
As we draw the curtains on the remarkable international conference in everything trends in mathematics and statistics, it's my honor and privilege to extend the heartfelt vote of thanks on behalf of the organizing committee and all the participants. First and foremost, our deepest gratitude goes to our esteemed keynote speakers, Dr. Madhusudan Ramasamy, Associate Professor of Head, Actual and Quantitative Studies, Asia Pacific University, Malaysia. Dr. P. Geeta, Principal, KPR College of Arts and Science, Coimbatore. Distinguished professors and researchers who generously share their expertise, insight, and cutting-edge research findings throughout the conference. Your contributions have enriched our understanding and propelled the frontiers of knowledge in the field of mathematics and statistics. We would also like to express our sincere appreciation to all the presenters and contributors for their thought-provoking presentations and engaging discussions. Your dedication and passion have truly inspired us all. Fostering a collaborative environment conducive to intellectual exchange and advancement. Our heartfelt thanks to our management and sponsor for their support in every way. Without whose support, this conference would not have been possible. Your commitment to fostering academic excellence and innovation is deeply appreciated. A special vote of thanks goes to the organizing committee, members, volunteers, and support staffs whose tireless effort behind the scenes ensured the smooth execution of every aspect of this conference. Your hard work and dedication have been instrumental in making this event a resounding success. Last but not the least, we extend our gratitude to all the participants for their active participation, enthusiasm, and camaraderie throughout the conference. Your diverse perspectives and shared passion for mathematics and statistics have made this gathering truly memorable. As we part ways, let us thank for the momentum gained from the enriching experience, continue to collaborate, innovate, and push the boundaries of mathematics and statistics research. Thank you once again to everyone who has contributed to the success of this international conference. We look forward to meet again in future endeavors. Thank you very much.
Thank you, sir. As we conclude this conference, let us carry forward the knowledge gained, the connections made, and the inspirations received to continue our journey of growth and progress. Thank you once again. We look forward to seeing you at our future events.
Let us take a break for lunch. Lunch is provided for all near the central library. All may gather back to this hall by 2 p.m. The presenters are divided into 4 slots. All must